Howdy folks, this is Clint Rawls with Delta Valves. I just wanted to do a quick video to show the how to set the travel on a 657 actuator. This one happens to be a 657 size 45. This valve is a 2-inch valve. The customer we're sending this actuator to is actually putting it on a 4-inch valve with 2-inch travel, but no matter. What we're going to do is show how to ensure the valve is in the seat and then set the travel. So you've got your 2 jam nuts here. What you'll want to do is run one of them up really far on the stem, because you want to make sure that your valve is seated first. Once you've got it up fairly high on that stem, you'll stroke the actuator down with a regulator, ensuring that it hits, pushes the valve. See, we were off the seat by about 3/8 of an inch. So now we're on the seat. We don't want to put a bunch of pressure on that because that stem's sticking way out, just enough to just push it down into the seat. Okay, now we can run our jam nut back down, and I normally run them down as far as I can get them. Just habit after doing thousands and thousands of them. Now, what I would typically advise someone in the field to do is to get your tape measure out and adjust one of your nuts to an even spot. See, I got a better way to do this. Mark it. So not mark it, but just note it. So right now the top of my nut is at 1 1/4 inch travel. And what I'm going to do is I'm going to stick a 5/8 wrench in here. That nut takes a 3/4 inch wrench. So I'm going to stick a 5/8 wrench under the nut, and I'm going to lift it up basically like so until I get for this valve 1 1/8 travel, but for a 4-inch would be 2-inch travel. Bam, that's exactly. So the valve touches the seat first, and you force it into the seat, then you raise it up, whatever your travel. 2-inch valves, 1 1/8 travel, 4-inch valve, 2-inch travel. So if it's a 4-inch valve, pull it up 2 inches, and so now you've got your bottom stop, which is your seat. The actuator has the top side of the stop already built in. And now all you have to do is make your connection. So put our stem connecting blocks on. Alrighty, so now what I've got is I've got the valve stroked 50%. I've got our feedback link on, and it's bolted on here. Now if you notice, it's 10 to 20, 30, 40, and then I think this might even reach close to 50 on the arm. That's millimeters. So whatever your travel is, just get on your phone, or if you're that good and you know it in your head, convert inches to millimeters, whether it's 2-inch, 1 1/8, 1 inch, 3/4 inch, whatever the case may be. Convert it to millimeters, and then with the valve stroked to 50%, this arm is level, you'll want to tighten this down on that measurement. So let's just, for example, we're just going to call it 40 millimeters. So I'm tightened down to where it's exactly on 40 millimeters. Then you'll come in, there's an external nut on this shaft. There's one behind it, one in front of it. You'll come in here, tighten it down, making sure that it's, the shaft is straight, not crooked. Just tighten it up, lock it in place, and then move on to tubing. You'll notice that I had to move this. The feedback link that I have is pretty long. So I started out from here, and then I ended up having to move it to the 3rd set of bolt holes from the bottom. More than likely, you've already got one installed on a 667 in the field. You're going to put it right back in the exact same bolt holes. No difference there. So anything I've done in this video, you don't have to do it exact. Do it as close as it's being done in the field currently during the changeout. anyhow, I'm gonna move on and get some plastic tubing run. All right, guys. So we reinstalled this positioner that came off of a 667 fail close actuator. We reinstalled it on a 657 fail open actuator. So we're going from a reverse acting actuator to a direct acting actuator. This positioner is very simple compared to many others as far as reversing the action of the positioner. So you'll want to kill your supply connection, and then this is your cam assembly in the back. There's a plate that goes crossways. It's connected to this feedback link. So as it goes up and down, it moves this just like that. This large screw here retains it. So you'll break this screw loose, back it all the way out. That spring does have some tension on it, but you want to be very gentle not to break that spring. And then all you want to do is flip it over. There's another hole at the top of the case for this to screw into. I'll try and stay out of the way while I do it in the video. There we go. There's a little pin on the back of this piece that I just took off. All you got to do is make sure it's on the riding on that cam. That's it. Now your calibration's going to be off. You got to recalibrate it. We'll go into that next. All right, gang. So we're getting a little further in. So travel set on the actuator. Like I said, on the feedback arm here, you've got metric dimensions. That's millimeters. So whatever your travel is, convert it to millimeter. At 50% of actuator travel, that arm needs to be level, and you need to lock that bolt down right on that travel mark. After doing that, now we're going to go into calibration. So you got your supply hooked up. Now you got your output. This is, I've been here since 4:30 this morning, so this is just kind of jerry-rigged. You know, it's plastic tubing. It's no big deal. It's just a demo. Don't use plastic tubing in the field, even though it's easy. All right, so we got our milliamp box hooked up. Positive, positive, negative, negative. And the first thing you want to do is go ahead. This is your span lock assembly. I hope you can see that well. There's a Phillips screw. You want to break that loose. And then underneath that is a flathead screw. And there's a positive and a negative. So from the bottom up, clockwise is to increase the span. Counterclockwise is to decrease the span. So if you're setting your zero at 4 and you go to 20 milliamps, just for instance, and the valve does not quite make it to the seat, that's because the span is too short. You'll want to go back to 4 milliamps. You'll want to come here, turn that span clockwise to increase the span, and then reset your zero. This right here is your zero. There's a black knob, and there's a minus and a positive. So anyhow, clockwise increases your zero, counterclockwise decreases your zero. So I'm just gonna mess this up right quick. So we're at 4 milliamps. I've got output. I know the valve is moved a little. So I'm going to go counterclockwise, and I'm going to decrease the pressure on that gauge, making sure that valve goes all the way open. And I watch this gauge to make sure the pressure drops completely off. And then you want your zero to be set just barely, like normally I like to get the gauge to jump up and then slowly bring the zero down until the gauge just falls off to nothing. So that's what I'm going to do here. Okay, the gauge just jumped up. Now I'm backing it back down very slowly. Wham. Okay. Gauge is at 0. 0 is pretty much as tight as it could possibly get. So whatever it moves at, a lot of guys say, oh, it needs to move at 4.2. Well, in a perfect world, that's true. Not all instruments are that precise. We'll see on this one. This one's not moving there. Kind of typical of a pneumatic positioner. And it barely moves at 4.4. So anyhow, there's 8 milliamps, which is 25%. Look fairly decent there. 12 milliamps is 50%. Spot on there. You can pretty much guess 75 is going to be on. And then 20 milliamps. So now that I'm at 20 milliamps, I want to watch this gauge and make sure that I fully load supply pressure. So it may hit the seat at, say, 20 psi or whatever the pressure, and the regulator's set at 30. So you want to make sure that when you hit 20 milliamps that gauge loads very slowly, but all the way to 30, if that's what the regulator's set at. That lets you know you're fully locked. Positioner's going full stroke. So we're good there. And the way I like to check is I just start bringing the milliamp source down. I'll start off about 19.5. 19.5, it's venting air, so it's reverting out of full load and starting to move back. That's perfect. However, this video is not, I don't want it to be perfect, so I'm just going to jack the span up a little bit, or actually decrease the span a little bit, and we're going to go through and recalibrate it. So at 20 milliamps, we're not quite loading up. We're falling short. So now we have to adjust the span. Anyhow, so I would go back to 4. Now we're going to go clockwise and increase our span. Now you see we increase the span. Now the 0 is off. So we're gonna back this span, or the 0 back counterclockwise until the pressure falls completely off the gauge. About right there. So now we're going to go up. Okay, yeah, we didn't get it quite good enough. So right there. Okay. Let's go back to 4. I do hear it venting, so it is going back down. I didn't do a good job of setting it at 0. Anyways, so now 25%. Yeah, looks fairly decent. 50%. I can tell it went just a hair past 50, which is good. That means it's going to load at 20 milliamps. 75%, beautiful, and 20 milliamps. Now we got to watch this gauge. Oh, I was incorrect. It's not loading. So we're a little bit shy still on our span. So now go back to 4 milliamps. We're going to give it not even a quarter of a turn clockwise to increase the span. So now we're going to reset the 0. You always have to reset the 0. If you don't reset the 0, it doesn't change the span on the other end. All right. So 4.5 is moving, so I'm going to go ahead and jump to 12, speed this video up. Looks good. Now 20 milliamps. Watch that gauge. Ooh, it kept on rolling. It's still moving. It's going all the way to about 25 pounds is what I've got the regulator set at. So now we want to see where it loads at. I normally like to go back to 19.5 and hope that it vents. That means your span is close enough. 19.5, it's venting. The positioner is out of lock mode. It's bringing the valve back, moving it. So anyhow, that's perfect. Now, one thing I got to remind you guys when you get this done, lock that span screw, recheck calibration, and put all the covers and bells and whistles back on, and you're good to go. I hope this works out well for you.